I'm unmuted. Yeah. Yeah. Okay. I assume that is great. Okay. So hello everyone. One moment of your attention, please. Folks on the table, fantastic. Thank you so much. So we're gonna start our workshop soon, or we already started it. So this workshop is currently streamed to YouTube channel. So in case you want to go back, rewatch it later, we're gonna add timestamps for you, so you can get back. GitHub Repo is there for you as well. And if you want to relive the memories, it's possible to do. So for those who watching us online, welcome everyone. So a couple of house rules in case you have questions. So it's only for online people. In case you have questions, feel free to ask them and we will get back to you. We'll read out your questions out loud. That's it. So we are happy that it's our first workshop this year. There are a lot of awesomeness gonna happen next couple of months. About that would be at the end of the workshop. But for now, I just give space our workshop giver, Josefine. So Josefine, your time to shine.
Hello everyone, I'm Josefine. I'm only one of the hosts. Actually, this workshop is co-hosted by my colleague Yasmin, Jeske, Crystal, and Phil. Thanks to every one of them as well to help me out here. I'm very excited that every one of you made it here despite the rain. That's very impressive, and I feel really honored that you are so excited about learning some beginner robotics stuff, that you don't mind all the raindrops. Who of you is here all by themselves? Nice, courage, cool. So people, please be nice to each other. Introduce yourself to your neighbor. This is something you can only pull up together. Robotics is a team sport. That's why we also have a pretty big team at Monumental. I'll quickly talk about what we do at the company. Then I'll talk about what I'm doing, maybe 5-10 minutes. And then we're going to talk on what you're going to do, which is actually the very basics of what we're doing here at this company. So what are we doing at this company? We do have bricks, and we get bricks from our clients. And our clients want us to make those bricks into walls. That's basically everything we're doing. How are we doing this? Client tells us where the bricks are supposed to go, so the architect gives us a nice drawing. We translate this drawing into a 3D model of what's supposed to look like with all the individual bricks already in the place where they're supposed to go. And the bricks go in front of an insulation, so there's already a backdrop at the back of the wall. And on this insulation, we put April tags, so stickers that help us with the localization. And then we take a digital reconstruction of those April tags. This is a 3D model, so something that lives in a computer space. And that's everything we do on prep on the construction site. Then we need the robots, so robots go in a van. We bring them from the office to the construction site. We put the robots in front of the house. Everyone comes watch because that's pretty exciting to see robots do stuff. The robot gets in front of a segment, and based on all the input with the 3D modeling and the 3D wall representation we made, the robot knows where it is and what it's supposed to do. And then the robot has this like virtual concept of what the house is supposed to look like. And then we press start. And then we come back 4 weeks later and we have a house done. We have done this multiple times last year, so it works. But yeah, it always has some new things. Every new construction site is different. We always have to learn new things. Like every construction site has its own new nightmares. And every time we have to do new things when we're on site. That's why I exist. What is my role? I'm a Forward Deployed Robotics Engineer. I was not aware of that concept before I got hired into that role. This is different things I do at work. On the right, my very favorite one, drinking kombucha. The second one, eating croissant. So when everything is going well, the robot does its thing and you just watch. Pointing at things is also something I like doing, just like right now in this moment. But I'm also doing programming. So basically my background is I'm an electrical engineer and I worked as a software engineer, always in a hardware context before coming to this company. And I'm going wherever the robot goes. That's why I have these shoes that have some mud on it, because I've been on the construction site today as well. And then the idea is something goes wrong on the construction site. We don't have to go through like a product manager and like a user researcher and UX A/B testing. Like, no, there's something going wrong on the site, and we have software engineers that are also where the robot is. I can directly implement something, make it better. So like the next day we don't have this problem anymore. And that's how we develop our robots. So we just take whatever is there. It's not ready yet for the construction site. We just put it there anyways, and then we'll make it work. And then every time we learn and we get a bit better. So that's on my role and what the company does. Let's talk about the robot. This is one of our robots, PISA 30. So we have them numbered. PISA 30, 30th robot, has a nice little Amsterdam logo on it. Let's zoom a bit in what is inside this robot. When we go really, really, really close, we see this. So who of you is surprised to see this as our code base? I'm pretty surprised, to be honest. So why TypeScript? Robots are very stupid. The robot has multiple actuators. Actuator is something that can move, and sensors. Sensor is something that can perceive something. Camera is a sensor. And the sensor just says like, I see this. And actuator says like, I go right, I go left. That's it. And all the logic, like everything that the robot is supposed to do, like where's the brick, where's the wall, where do I have to drive, what am I going to do, what I'm supposed to do, what's my purpose in life, that's in TypeScript. And then we have a Rust layer that kind of compiles multiple of these movements. So when you say like, I want to drive from A to B, the Rust side of the code will explain like, okay, when you want to drive to A to B, this is like the most efficient way to do left, right, like with the different actuators. And the thing that we are going to do now is like, we're going to use Python for this. In our company, we use C for that. That's only 2%. So if you think what we're doing today is scary, you're not alone, because I think that's the same. It's fun also to play with hardware. But it's a really, really tiny part of what we're doing is to make the actual hardware work. Because once the hardware is working, the complexity on top of that is much more work. And we also have a really, really big Python code base, which runs, for example, our computer vision models in there, and like other functionality that is a bit more complex than just going left, right, on, off. So yeah, this is our code stack. Here a little video on how it translates. So we have this front end thing, and that translates to the robot moving something in the real world. Okay, let's zoom a bit closer now. We already like seen this part of the robot. Let's go even closer. Here, the arm, when we go even closer, we see this. So every one of you got a little bag from Santa Phil. If you haven't gotten one yet, you will get one in a second. In there, we have the scary thing on the top right. That's called a microcontroller, and a servo motor, and some cables to connect the servo motor to the microcontroller. And that's literally the same thing we have in our robot. There's also an additional sensor to tell like where exactly the motor is now turning. But this is how our arms work. There's a motor and a microcontroller, and the microcontroller tells the motor turn left, turn right. And then we have a sensor report back like, oh, actually, like you told it to turn 2 degrees, but actually it did like 1.98. That's important information if you want to be very precise. What is a microcontroller? It's like a very stupid computer. Your washing machine has a microcontroller in there. Your car key has a microcontroller. Like all the electronic things that have kind of some logic. So microcontroller is anything that can like convert a random input to an output. So yeah, that's a very, very basic of controller. What we're going to use in this workshop is the ESP32. It's a really cheap microcontroller. That's why we can give it to you. You can take this home, actually. It's a gift for you. So you can continue playing with this. So if you don't finish the workshop right here, don't be stressed. You can continue playing with this. And the servo motor is, there are also different types. I hope we gave you all the same type. If there's someone who got 360, okay, Phil gives his thumbs up. So we all have the same type of microcontroller. All right. Actually, I lied. So this thing is not a microcontroller. It's only the left thing, the big chip on the left, that's the microcontroller. And the microcontroller has a lot of legs on the side. And these legs are called pins. Pin, remember that word. You will need that later. We will be looking for one specific pin later. That's going to be our first treasure hunt. And what we have here is a dev board. So it's a development board where the microcontroller is already placed on top. And there are other components connected. So we can play with those components without having to connect them because cables are annoying. And we thought it's nicer if we don't have to like wire all the cables ourselves. So someone already did that for us. We can zoom even closer to make it even scarier. So this is how the board looks inside. We don't care actually. But we could also zoom even closer. This is how you would plan to make something like this. Here you have a bit of an overview how everything is connected. In the top middle picture, you see the ESP itself. So to go back, the big gray box on the left is the picture in the top middle. If you're interested, you can try to read the schematics, not necessary. Even more abstraction, I'll just show you these pictures so you understand it's not so scary. Like, I mean, it looks scary maybe, but on the other end, we have the same gray box again in the middll, like ESP32, and it's connected to a LED. LED is on the board itself, and that's the thing we're going to use for the workshop. So we're going to get started in a bit. I know there's some setup as well required as well, but I will quickly walk you through what we're going to do in the workshop. The workshop has 3 parts, maybe 4 parts. The first part is to get your laptop set up, get the requirements in, like install the repository, make sure you can upload something to the microcontroller. We have some people here who can help you with that. Who of you already has experience with microcontrollers? Who thinks everything I said is not scary? I see 1, 2, 3. Anyone at this table? No, no one at this table? Okay, so we have 3 tables that already have someone who's experienced. If you have questions, you can also ask them. And you can also ask the AI. Everything we have here is very common components. So Claude, ChatGPT, they all know these things. So they can also help you. The LED blink is the hello world of hardware. So whenever you get a new hardware component, you make an LED blink first, because that's one thing where you get easy feedback from the hardware. Is it connected? Can you upload code? And the cool thing about the LED that we're using on this dev board, it can blink in all colors. So you can even choose your own color. And to give some intro on how hardware programming works, hardware programming typically has 2 parts. Part 1 is like, when I wake up, how do I know what I'm supposed to do? And then part 2 is like, keep doing that for the rest of my life. When you press your car key, you want the car to open. So the car key will listen, is the button getting pressed or not? And when the button finally gets pressed, like a little dog that waits for the person all day, it's gonna open the key, open the car. So we have the setup part, and then we have a true loop. So the while true is basically while it's on, just continue doing that. So we will set up the LED at the start. So we have to tell the ESP where the LED is. That's why I was showing these schematics before. All the different hardware components come with data sheets. So the manufacturers will tell like, okay, I made this piece of hardware. This is how you can use it. And this is how everything is connected. And again, the microcontroller has legs. Those legs are called pins. And one of those pins is wired to the LED in order to control the LED. So we have to tell the ESP where it can find the LED, because the ESP is too stupid to find out itself. It's a very stupid computer. So we have to tell it. In the code, I put 0, but that's wrong. We have to find out where it's connected. And then we need to initialize the LED. Python is amazing. So we're using MicroPython in this workshop. So the microcontroller that you have is already prepared. It's like a Python interpreter. It has all these packages on it. So you don't need to install anything on the microcontroller. You can just upload the code and it will execute what you tell it to do. So we're initializing the pixel. So the library we're using is called NeoPixel. It's made for huge screens. And an LED, like a single LED, is also a screen, but like a screen with 1 pixel. So we're going to tell 1 pixel to turn on and turn off and sleep half a second in between. That's going to be the first exercise. I haven't linked the GitHub repository on the presentation, but the meetup page has the GitHub repository linked. So you can find the GitHub repository of the workshop over there. Yasmin and Jelske can also help you set everything up. So can Phil, so can I. So please, if you're stuck somewhere, don't worry, just raise your hand and we'll come help you. All right? Happy coding.
Let's just check if you're actually going to need it. So very nice example. It's already just to solve. So I think Also, why people are going to struggle with
So you have
the other one's got like a long series of numbers.
because I think that's a machine when they try to try to
It's just getting
Josefine, we need your help. So explain us. And when we try to run the command system to find the word, it says that dosage power. So that's
There's a I think the live stream. Just follow the guy.
Is that a question? Anyone?
So I think it's probably but I still have issues uploading a file to the USB too. So whenever I was it was part of it, just I think since it's
So that should be okay. I think it's just looking for something else when it's not actually. Have you installed
yeah, I think it's tools, and material.
Trying to figure out which this is.
The Windows
Yeah, I found it very complex.
Even though I but it's still not able I didn't expect
I have run into some issues sometimes with desktop permissions. Sometimes it doesn't let you run the code out of subfolders on Mac. But you can somehow set it. So it may have issues with subdirectories if it's in new place. Have you got these?
Oh, I already got that.
Yeah.
Okay, just install. Is it supposed to go with the
Perfect. Yeah, give it a go. Oh, yeah.
Well, this is the thing. I only want someone here. You should get like
So this is fine. So they usually have one. So we've got one of two. You don't have to write. Just having issues with listening to the I'm gonna try
I have to say though, I think two of you otherwise finally do that.
starting to see the correct colors. Amazing. Stage one complete.
Stage one complete, yeah.
Amazing. You're working good. Each one, teach one. Help us. How are we doing? Okay. Sure. Where did you manage to find the correct thing?
I just asked this guy basically. No,
I just told you a valid way of finding it.
No.
I mean, you could just search. I see somebody sequentially going through all of them until it works. But know how to control it. Absolutely. If you just know the model number and the data sheet will tell you.
Yeah.
It even gives you a decent like a Gemini, like if you're looking for the pins, there it is.
How do you like if you get a chip in your hands, how do you know what to do? I don't think it has a
So there's a couple of things. So what you'll see on the back is just a tiny little number.
Yeah.
Tells you what hardware it is.
Yeah, so it moves that. Right.
So the pin tells you exactly what
I was gonna write some French.
On every step that you're going to do next. It's pretty bright.
You go pretty fast as well.
Yeah. It's kind of weird to talk an accent. We're everywhere. There's a couple of us in the company as well.
All right. Who of you has a blinking LED already? All right. You also have a blinking one. Okay, good. Who of you doesn't know which port it is? Which pin it is?
Which pin?
Pin. Okay. I will give the answer to the pin. It's 48. If you have an old board, it could be 38. Try both these numbers. How do I know this? On the data sheet, there's a table which lists the components that are on the dev board, which says there's a RGB LED, which is driven by GPIO 48. It's very hidden. I can figure this out. Who of you has problems to upload code at all? Like over here. Who has a Windows computer and has problem uploading code? We have one person here who has a Windows computer who figured it out. Who has a Mac computer and cannot upload?
Yeah, so just need
You have Mac?
So then the next step is to so instead of port, you will replace You can hear it. So they're both 0 wheels. One is that so it's just a little bit easier. More crazy.
First, 16,
which is the left. Unfortunately, they just kind of like stumble it. And 16 more.
Ah, there we go. So it says
As far as I know, that just has a different amount of memory.
yeah.
Oh, this is the list of the I need to figure out my listing.
One more hint.
Funny, it's not.
If you uploaded the code successfully, but your SD is not linked,
Gemini hasn't like
try
done
and
all
press
summary.
the reset button on the microcontroller. So RSD. So we click that and then you can start working.
And I just spelled out 48 and we're like, why is this so? Yeah, and we're going to some of our old
It's lagging behind.
Sorry? Yeah?
Success is spreading. Fantastic. What was the And then what we run is allow scripts to be sent directly. It says like, sorry, it's on a desktop and documents you can't write anything, which is sub-directed. Sorry, that's oh, you're working inside double different. Okay, I understand why though.
So this is now I'm telling it to self-pick and then black. And we should go from 10 to green.
Something is
Turn green into green, turning it into green until it's pink. And then we go so this is how I upload it. This is how I bring whatever is into this. We use cursor or visual VS Code.
Yeah.
Any.
Yeah.
I'll get to one. Okay. Sorry, I want to interrupt you real quick. Some of you, who of you has a blinking LED? Show it. Show your blinking LED. Nice, good job. Good job, everyone. For the ones who have the LED running already, who has no blinking LED yet? Please raise your hand. So we have 1, 2, 3, 4, 5. please help your neighbors. If you have no blinking LED and it's still not working, please try to find someone to help you. We really want that step working today, because if you have your LED blinking, you can continue later at home. For the ones who have the LED running, we can do the next thing, which is wiring up the servo motor. For the servo motor, we have 3 cables: the power cable, the ground cable, and the signal cable. And you can follow the instructions in the README on where to connect everything. And then you can start making the motor turn following the instructions.
Yeah, you had it, but it was full. Yeah, it needs to
Yeah, that's the same command.
just
Maybe whatever. Yeah, whatever was there. Wire of the motor.
The connector one says company. This is USB and has serial that we plug. We already have plug. That is plugged to company. So why you can say your device manager? Yeah, I know. Yeah, in the command you write from A to Z. Yeah, try it. It's a control stand. So try this command instead. So right side multiple ones and they didn't copy work because you have to add file to your environment server. And
So the it's in the README as well. I will share it on the big screen.
Dash and flag double dashboard for free input. Tap it's a Greek. It's a package.
So the black wire goes into the ground pin. The red wire goes into 3.3 volt. And the yellow wire is going to a GPIO pin. And you will need the extra cables. So that's why you have the extra cables.
Yeah, because it works online. Oh, yeah. Yeah, the terminal. You're welcome. Yeah, it's a green terminal. Oh, yes, to update our code. So it's now working. Yeah, but I worked with engineering really careers in robotics. So I have like 3 products in microcontroller. You're welcome. Felix, nice to meet you.
Maybe we have the answer. Let's try this. So the way to run this is
Like a mouse.
Do we have any issues with ALDI?
They're helping me. Okay, so yeah.
Because the thing is, so we can start a coding process. It's paid at this moment. But an API, so like a CLI.
Red, white, black. Yellow, cool.
So when you try to run it,
Maybe together.
I use an I didn't work for me, right? It's the same one.
That's strange because like we install everything. That's check and then yeah. But now like multiple
Test.
yeah, so now you have to and then but just like if you try to distinguish okay, attention. Folks, we need your attention for a second.
All right. Who of you has a moving motor? Yes, nice. Good job. So a robot can move things, but it's worthless if it cannot interact with its environment. So as a step 3, we are interacting with the sensor. The ESP32 that you have has actually a Wi-Fi module included. So I highly recommend you everyone to play with the Wi-Fi module at home. Right now, we don't want to do that because it's going to be too much Wi-Fi here in this room. But we have another sensor that we can use. The GPIO pins of the ESP32 can be used as a touch sensor. So every one of you got 4 cables. 3 of those are to connect the servo motor. And the 4th one we can put on a random pin and configure it as a touch sensor. So the example code that you will see in the library, that will make the LED blink once you touch the sensor. What would be fun is if we can touch the pin and make the motor turn based on the touching. So what I recommend in the example code is that we turn it to the left if we touch once and turn it to the right if we quickly touch twice. So that would be like, if you manage to do that, you already have like a fully functional robot, which is basically the same as we do in this company. If any one of you is any one of you still stuck with making the LED blink? One more person. Which environment do you have? Mac, Linux, or Windows? Windows, okay. And you? Yeah, okay. So please help the people who don't have the LED blinking yet, because we really want to have that working before we go home. And for all the rest of you, if you need to help wiring up the servo motor, so the servo motor has 3 cables. It's the brown one, the red one, and the signal one. You can connect any other color to it and wire it to the ESP, to the corresponding ports. 3 volts, ground, and the GPIO 15 is what I used for the example code. But you can connect it to any signal pin. If you need any help, raise your hand and I will drop by.
How's it going, guys? Yes. Screen of the party. I genuinely, I always want to start right, which is good, because otherwise I feel like but there's really something I need yeah, but then it takes forever. Yeah. I mean, you finish at 3, but then you gotta go like, yeah, to the office.
2 minutes of your attention, please. We need to close the online part and then we can continue. Okay? Thank you.
All right. So I hope you managed to get somewhere in this workshop so far. If you haven't, there are multiple ways to continue on this. You can connect me on LinkedIn and ask me questions there. If it's not too many, I will probably answer. Another way is you can also comment on the GitHub repository, make a PR, complain about the README being not correct, and I can answer over there as well and help you to make it work. I'm really, really happy every one of you joined here and online, of course. And I really hope that you had some fun playing with the hardware. Who of you enjoyed this? Nice, cool. I also enjoyed that. And I'm really happy that every one of you got to some point in this workshop. We'll still be around for a bit. Thank you everyone online for joining us. Please check out our website, see cool videos of our robots over there or job opportunities if you care. And hope to see you again. Thank you.
Before we close out, one announcement real quick about the next event.
Julia.
Oh, sorry. Hi. The next event, yeah, we will have an open source sprint again this year on the 27th of February. So it's going to be our next event. It's not been officially announced on Meetup yet, but it will be in the next few days. So please keep an eye out for that. This time it will be at the Adyen office and it will be MLOps engineering related. So we're looking at libraries like MLflow and Kdro to contribute something open source to, give back to the community a little bit for libraries that, I don't know about you guys, but I use a lot. So that would be quite nice to give back there. Yeah, I think it's going to be fun. Check it out, and I hope to see some of you there. Thank you, everybody.
And to everyone who's joining online, of course, also you are meant with We Are Hiring. So if you feel this is interesting and you want to play with robots more in the future, please check out our job opportunities and give us an application.